Hi everyone, today we're going to start with a new unit, the unit of exponential and logarithmic functions. This is the first lesson on exponential functions. You have seen them last year, so we're going to go into more details this year. Just as a quick review, I'm going to mention that the exponential functions are in the form y equals b to the power of x. And just like any function, they can be transformed according to the transformations described by the coefficients a, that causes vertical stretches, the coefficient k, that causes the horizontal stretches, the coefficient d, that causes the horizontal translations, and the coefficient c, that causes the vertical translations. So we're going to start by graphing y equals 2 to the x and y equals 1 over 2 to the power of x. We have two separate grids for them, and we're going to use a table of values to graph. So I'm going to give x certain values for the first function, so x here, and y here, which is 2 to the power of x. And for the second graph, I'm going to give x values here and y values equal to 1/2 of x right here. Now, when you think about it, the independent variable is in the exponent, and that's what gives these functions the name exponential functions. And if you give x a negative value, then you're able to find the value of 2 to the power of a negative. If x is positive, we can definitely find the value of 2 to the power of x, 2 to the power of a positive number. And if it is 0, we still are able to evaluate 2 to the power of 0. So that makes us think that the domain for this function can be any real number. And I'm going to make a note of that. So x can be any real number. And in the meantime, I'm going to select my x values here. So I'm going to pick some negatives, 0, and some positives. So I'm going to evaluate the values of y here. So y equals 2 to the negative 3. That's 1 over 8. Y equals 2 to the negative 2. That's 1/4. Y equals negative 1. Negative 1 is 1/2. Y equals 0. X equals 0. Y equals 2 to the 0. That's 1. Y equals 2 to the power 1. Y equals 2 power of 2. And y equals 2 to the power 3. I'm going to plot the points. Here go x and the y-axis. And I have very small squares, and I think I can afford x values. 1 unit to be, on the x-axis, I can afford the 1 unit to be the squares. So I'm going to write here 1, 2, 3. I won't go any further. Why do the extra work? So, and then for the y-axis, we have 1, 2, 3, 4, 5, 6, 7, 8. That's how far I'm going to go for now. So here we go. We're going to plot the points. So when x equals negative 3, the value of y is 1/8. Okay. Where are we? So negative 3, 1/8 would be a point somewhere in here. Very close to the y-axis. I just have to eyeball it. It's kind of hard to figure, to mark 1/4 of a small little square here. When x equals negative 2, y equals 1/4. So that's 1/2 of the square. Negative 1, 1/2. 0, 1. 1, 2. 2, 4, 3, 8. Okay. Now it's time to connect the points. So as you can see in here, the y values never became 0. They always stayed positive, as a matter of fact. Let's talk a little bit about it. So why can't the value of y equal 0? Well, think about where the values of y are becoming 0. So y values are becoming 0 as we move towards negative infinity for the x. So imagine x being negative infinity. If x is negative infinity, what's going to happen to y? So y would be 2 to the power negative infinity, or otherwise 1 over 2 to the power positive infinity. So that's 1 over infinity, close to 0, but never 0, so above it. So that's the reason why we're going to say that the range of this function is any real number, but y has to be positive. So is this function increasing or decreasing? Well, to judge about it, to draw a conclusion about it, then we're going to read the graph from left to right, just like we read a book. So we walk along the line and we see where the pencil is going. So it's going up. That means the y values are increasing as we move left to right. So it means that the function in this case is increasing. And how about the y-intercept? So the y-intercept is where the graph intersects the y-axis. So it's right here. You can see it's at the point where x equals 0 and y equals 1. And we're going to write that down. So y-intercept equals 1. You may as well write 0, 1 just by indicating the coordinates. That's sufficient enough. And asymptotes. So as we mentioned a few seconds ago, the y values will never become 0. So if the y values never become 0, that means that there will be a barrier or a wall here that won't allow the graph to cross or to go to the other side of it. So that means is that the graph has a vertical asymptote, horizontal asymptote in here. Sorry about that. My phone was ringing. So y equals 0. That's the equation of it because the asymptote is passing through the why is that? I want to draw a very straight line here, but that's okay. It's passing through y equals 0, and it's a horizontal line. So in the same way, we are going to draw the graph y equals 1 over 2 to the power of x. So let's give x the values from negative 3 to positive 3. And we're going to say y values here would be 1/2 to the power negative 3. So that's 2 to the third, 8. Similar to this, 1/2 to negative 2, 2 squared, or 4. Y equals 1/2 to the power negative 1. That would be 2. Y equals 1/2 to the power 0. That's 1. Y equals 1/2 power 1. That's a half. Y equals half to the power of 2. 1/4. And last but not least, that's 1/8. So just like we did with the previous function, we are going to draw the graph here. So here goes the x and here goes the y-axis. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3. So let's plot the points. When x equals negative 3, y is at its highest. Negative 2, 4, negative 1, 2, 0, 1, 1/2, 2 1/4, and 3 3/8. So let's connect the points. Nice, smooth curve. Let's describe the features of this graph. So the domain, just like in the previous example, x is any real number. For the range, we still notice the same thing. Y is any real number, but Y has to be positive. Is it increasing or decreasing? So if you walk along the graph here, you can see that as you go from left to right, the line is going down or the curve is going down. So that tells us that the function is decreasing. Does it have a y-intercept? So I look at the point where the graph intersects the y-axis, that's 1. So we're going to say that the y-intercept equals 1 or 0, 1 again. And the asymptote, it's the same as it was in the y equals 2 to the power of x function. So we're going to write, well, it does have a horizontal asymptote. And the horizontal asymptote is at y equals 0. That's the equation of it. So if you compare the two graphs, you can see that these are both the same shape. They have the same shape, and the only difference between them, they have the same domain, the same range, same y-intercept. So same domain, same range, same y-intercept, same asymptote. The only difference is the fact that the first is increasing, the other is decreasing. And the reason why is because of the base in here. That's the only difference. That's the only difference between the equations. If you look at it from the algebraic point of view, and I'm just going to write a short explanation here. When we work with y equals 1 over 2 to the power of x, we can also look at it as 2 to the negative 1 to the power of x, or 2 to the negative x. So this negative here before the coefficient x indicates that the graph has been reflected about y-axis. Sorry. All right. Okay, that was the first part of the lesson. Moving on to the next part. So I'm going to record it in the second